Hi everyone, and welcome to another very exciting tutorial. Today we're going to create a pretty simple game, but we're going to use Apple's 3D graphics framework SceneKit to do that. So this is going to be pretty interesting, and this is meant to be a very quick starter tutorial to familiarize you with SceneKit. And if you like, we can create more game tutorials using SceneKit. Just let me know in the comments below. But before we get started, I'm also very excited to tell you about my new Numa Community. For those of you who know the Swift Tutorial Conference last year, this took place on Numa. We used their service to host the conference, and now I have created a completely new community, which you will find in the video description link below. You can subscribe for $5 a week, and you get a lot of stuff for these $5. I'm going to create a separate video on that, but just that you know that this exists, have a look at the video description below, and if you're interested, watch the other video dedicated to this new Numa community. But now let's directly start by having a more detailed look at this game. As you can see, we're firing kind of pyramids into our space. We can move around here, have a look at all of the scenery here, which is, as I said, pretty simple. And what we can do is we can press on those elements, and we should focus on only pressing on the green ones. If we press on the red ones, we get this indication that something isn't too good because we get a red background color, and as soon as we press on one of the green elements, all returns back to normal. So as I said, very simple, but I think very interesting to get started with SceneKit. So let's open up Xcode and create a new application by pressing Command-Shift-N, and we're going to select the game template in the application section, hit next, and let's just call that simple 3D game, and just make sure to select SceneKit as your game technology. And if you've done that, let's hit next and create that project on the desktop. And Apple provided us with a lot of stuff in this template, so let's just have a look at what's maybe different to a standard single view application. For example, we have this Art SceneKit Assets folder where you can place all of your assets like textures and also the 3D models that you can generate for SceneKit. But we are not going to focus on that in this tutorial. So what we can do is, first of all, remove that from our project. We're going to deal with something like that if you want in another tutorial. And what we have got is a game view controller that was also generated by Xcode for us. And there is a lot of template code, but we're going to focus on creating a lot of this stuff ourselves. So let's just quickly remove all of that template code from view.load, for example. Let's just quickly remove that. Also the handle tab function, we can remove that for now. And the rest of the functions like should auto rotate and so on, we will keep that in place, and we're going to do lots of the things just in code to familiarize you with the classes that exist in SceneKit. And the first things that we're going to do is creating some properties. We're going to start with a game view, which is an object of type SCN for SceneKit, and then we're selecting the scene view. Then we're also going to have a game scene, which is going to be an object of type SCN scene. And what else have we got? We have a so-called camera node, which is an SCN node. And the last thing that we're going to have is for the creation time for our little pyramids here, we're going to have a target creation time, which is a time interval, and we will initialize that with 0. So what is a game view, a game scene, and a game node? Let's maybe start by talking about nodes, since we have just created a camera node, which is a object of type SCN node. And in SceneKit, each element of your game, such as lights or a camera or geometry like our pyramid, are called nodes, and the game scene, which is a object of type SCN scene, provides a hierarchy for you where you can attach all of your geometries, lights, and so on, so where you can attach all of your nodes. And then the SCN view, or the SceneKit view, is the place where you can add your scene, and you can place a scene kit view in your view controller. And this is already done by Apple here in our template, where we have a scene kit view in our game view controller. So these are the new objects, or the new classes that we're going to play with in this tutorial. And the first thing we should do is actually initialize our game view. And we can do that by creating a new function here, which I'm going to call initView. And what we want to do here is, first of all, populate our game view. So what I'm doing here is taking self.view and cast that to a SCN view, because we already can access our view here, and as you've seen in the template, this is a scene view, so we can also cast that and work with that as a game view later on. What else we want to do is, for our convenience, take the game view and allow camera control, which gives us a great way to manipulate the camera without having to code anything. So as you can see here, I can move the camera around by just pressing and hold and turn this around. I can also zoom by pinching, for example. So this is a great way to play around with the camera a little. So I'm setting this to true. And then also what I'd like to do is taking our game view, and so that we do not have to worry about lights in this tutorial, we auto enable default lighting. So I'm also setting this to true. And now that we have our function for initializing the view, we can continue with creating another function to initialize our scene. So let me write init scene right here. This is another function that we are going to implement right now. So we first of all need to initialize the game scene object. So I'm taking the game scene object and simply initialize it with scn scene. So we do not need to add any parameters into the initializer. And then we have to add our scene to our game view that we already have initialized. So I'm taking the game view, access its scene property, and simply assigning the game scene. And the last thing that we want to do is actually taking the game view again and set isPlaying to true. And this is important because by default, SceneKit enters kind of a paused mode when no animations are taking place. And this forces SceneKit into endless playing. So this is just one little adjustment that we make here at the end. And one last thing that we are going to need is a camera. So we write another function, which I'm going to call initCamera. No parameters needed. And what we want to do here is, first of all, create or initialize our camera node. So I'm taking this property and initialize it with an SCN node. And now that we have that node, we can access it using the camera node and access its camera property and initialize it with an SCN camera. And with that, we're almost done. And what we can do now here is adjusting the camera's position, for example. There are other important properties like the field of view, for example, but again, this is something for another tutorial, so we're just focusing on positioning our camera in 3D space. So since we're in 3D space, we do not use coordinates based on an X and Y value, but coordinates in X, Y, and Z values. And what we do here is, using a camera node, access its position, and then create an SCN vector 3. So we have 3 vector components, an X, Y, and Z direction. So X will be 0 for our case. Let's use Y as 5 maybe, and Z about 10. So we're moving the camera a little more to the front. And now that we have all these functions initializing our properties, we should also call them, and a place for that would be view.load. So I'm calling the initView function, the initScene function, and the initCamera function. And if we now run this in the simulator, this should work nicely, but we won't be able to see anything because we have not yet created any objects, but that's something that we are going to do in a second. Let's just see if everything works so far. So we are right here where we want to be. We do not have any background images or anything like that, so we just get a black screen. So let's change that by creating yet another function. Let's call that one createTarget. And our target is going to be a geometry object, because there are several standard geometry objects included in the SceneKit framework, like a pyramid, spheres, cubes, stuff like that, that we can create directly here in code. And we do that by creating a geometry object, which is a SCN geometry object. And what we can assign is, for example, a pyramid, SCN pyramid, with some standard properties like width, height, and a length. I'm simply choosing one for each parameter here, and with that we're good to go. And then what we can also do is giving our geometry object a specific color. So I'm taking the geometry object, access its materials array using the first object, its diffuse property, and its contents. And here we can simply assign a UI color. So let's say UI color red, for example. But to display or to add our geometry object to our scene, what we need to do is create a geometry node. So here we go, and this is going to be an SCN node that we initialize with a geometry object, which is geometry in our case. And now that we have our geometry node, we can simply use our game scene, access its root node, and add a child node, which is our geometry node. And when we now run our application, we should be able to see a nice little and red pyramid, and also giving it a little camera flyby. But of course, only if we call the create target function. So let's quickly do that in view did load and run this again. And now here we go. And there is our pyramid. And if we zoom out a little, this looks already pretty nice. So we can move around our pyramid, having a look at it from the top, from the bottom, and so on. So with that, we have our first object, and we can continue to modify our target for our game. For example, we can change the color randomly so that we can choose if it's a green target, so a green pyramid, or a red pyramid. And to do that, what we should do is, after we have created our geometry object, we should create a random color object. So let's call that random color, which is going to be a UI color object. And what we can do here is use arg for random uniform with an upper bound of 2. And if this is equal to 0, then we want to use UI color green. And in any other case, we want to use UI color red. And then instead of assigning a static value here of red, we will simply add random color here. And to later identify which kind of color, so if we tap an enemy or a friend in our game scene, or the user taps one of those two kinds of objects, we have to give our geometry node a name based on the random color. So we can check if our random color object is equal to, let's say, UI color red, then we give our geometry node a name, which is, let's say, enemy. And in any other case, we give it the name geometry node.name equals friend. And with that, we can later decide what kind of a pyramid our users tap. But what we also should think about now is how we can actually animate our pyramids, since at the moment they're standing absolutely still. And there are different ways to animate something in SceneKit. We could predefine the animations that we want to apply, or we can simply use the physics engine and apply physics to our pyramid. And to do that, we have to use our geometry node again. So I'm taking the geometry node and I access its physics body. And here we can create a new SCN physics body and initialize it with a body type and a shape, and there are basically three types of physics bodies. The first one is static, then there is dynamic and kinematic, and a static body does not move while other objects can collide with it. A dynamic body, for example, they are automatically moved by the physics engine in response to forces or collision, so this is obviously what we want here. And if we pass along nil here as a shape, Scene-Kit will automatically approximate the physics body based on the visual form of our geometry object, so our pyramid in that case. And with that, with adding a physics body to our geometry node, we can make sure that physics can be applied to our pyramids. And to actually apply physics to our pyramid, what we can do is create a so-called force. And forces are also defined as vectors. So we will create a new, let's do that after we added our geometry node. We will create a new force object here, and this is going to be an SCN vector with 3 components. So again, we have X, Y, and Z, and I somehow hope that we get code completion here, but for some reason we won't. Oh yes, now it works. So for the X value, I'm simply entering a number, let's say 1 here, but we want actually to have a random value here so that our pyramids are going to be a force to the left or to the right. We are going to deal with that in a second. Let's add about 15 in Y direction and 0 in Z direction. But as I said, we want our pyramids to be forced either to the left or to the right, but that should happen randomly. So let's create another constant. Let's call it random direction. And again, we use arc for random with an upper bound of 2. And if this is equal to 0, then we want our pyramid to move to the left, and in any other case, we want to move it to the right. And this should be, of course, a float value, so I'm specifying this right here by specifying the type, since our SCN vector requires a float value, and then I'm simply entering my random direction for the X component of our vector. And what else should we do? Well, we should now apply our force to our geometry node. So we're taking this node and simply call its physics body and tell it to apply a force with a direction at a specific point, and we want this to be as an impulse, which means that we apply the force once and not continuously. So the direction is our force, and we can create a point for the position where we want to apply our force, again as an SCN vector with the 3 components. So I'm going to give it a slight offset to its center, so Y 0.05, and also for the Z value 0.05, and this should be applied as an impulse. And with that done, we should see our pyramid moving a little bit. So let's run this again. And as a next step, we will think about how we can actually create many of those pyramids. And as you can see, we just saw kind of a movement, and there it goes. It just drops into kind of oblivion. And we only have 1 pyramid, but we actually want a lot of pyramids generated periodically. And how can we go about that? How can we generate pyramids automatically? Well, we are going to use the render loop for that, and the render loop consists actually of 9 steps that are performed each frame, starting with an update state, then there is a did apply animation, did simulate physics, and so on. We do not go into detail about that in this tutorial, but we're going to use the update method or the update function that is part of the scene render delegate, and there are functions associated with each stage of the render loop, and to work with that we have to adopt the SCN scene renderer delegate. And we also have to assign self to that delegate. So we do that in our init view function, and we're using our game view, accessing its delegate function and assigning self to it. And then we can also use the update function of that delegate, which is update at time. And the renderer update at time function is going to be the place where we will have a look also at our target creation time. And there is also an argument called time in this delegate function. And what we want to do is we want to check if the time is greater than the update, how did we call it? Target creation time. So if the time in this function is greater than the target creation time, then we want to create a target. And we have to, of course, update the target creation time. So target creation time equals the current time plus, let's say, 0.6 seconds. And then what we also should do is remove the create target function in view.load. And then we can run our application in the simulator again and have a look at how many objects are actually generated. And as you can see, we have a lot of objects already generated. As you can see, they are red, they are green, and they are thrown into different directions from a specific point in our 3D scene. And while we're here at the top, let's also have a look at our init camera function just for a second, because I just noticed that when we run our application, we still have kind of a not so interesting view at our targets, as you can see here. This doesn't really make sense, and we should, of course, add our camera to the game scene. So I'm taking the game scene again here in our init camera function, access its root node, and then we add our child node, the camera node right here. And if we run our application again now, we should definitely see our whole scene a little better. So let's have a look. This is definitely better, and as you can see, our pyramids are moving nicely as we intend that, and we can still move around, seeing them falling into oblivion. But the problem still is that although they are getting invisible after some time when they drop too deep, they still remain in existence. So we should create a function to clean up our mess a little. So we are creating a function. Let's also call that cleanup. No parameters needed. And what we want to do is, using a for in loop, we are going through each node in our game scene's child nodes array. So we're using for in loop here, creating a node object, and we're using the array game scene root node and child nodes. This gives us an array of child nodes, and then we will check each child node if the node and its presentation and its position and its y position is lower than -2, then we actually want to remove our node from the parent node. And this is something that we should call right after our creation here in the update at time function. So every time we go through this function, we're checking if there are nodes that we can actually remove. And the last thing that we should think about is, how can we actually check which of our pyramids is tapped by the user? And therefore, we're using a very simple function that you might also know from iOS, standard iOS development when you're working with touches, which is the touches began function. And here we first of all need to get a touch from the touches set, and we're simply taking the first touch that we get here. Then we create a location object using the touch, its location property, in our game view. And we are going to use this location to perform a hit test to see which object we actually hit in our game scene. So therefore, we create a hit list with all of the objects that we might get from that location, that are at this location at the moment we tap it. So we use the game view, perform the hit test function. As you can see, it returns an array of SCN hit test results, and we need to specify a point, which is our location. We don't need any options here. And then we simply use the first object out of this hit list. So we create an if-let statement here with the hit object as an object to use the hit list and the first object. And then from this hit object, we actually need the node to check the name, if it's a friend or an enemy. So we, again, create a node object using the hit object and its node property. And then we can check if the node and its name is equal to, for example, friend at first. We use that node and simply remove it from parent here. You could increase the score or do whatever you actually like. And what we also want to do is using self and the game view and change its background color to UI color black, because if it's not a friend, what we want to do is first of all also remove this node from parent, but also change the game view and its background color to red. So let's change that to UI color red. And this is how simple actually touch handling is in our case. We can now run our game in the simulator and see if all of this works. So let's see. I press on the red one and we get a red background color, and I press on the green ones and nothing happens, but our nodes are disappearing. So this is actually exactly the behavior that we intended. And with that, we have completed this first very simple 3D game, but you've already seen a lot of interesting things about the kind of classes that we are using in SceneKit, the delegate function, or the delegate functions of the renderer delegate and the render loop. We used the update at time function to generate new targets. We have removed those targets to save memory. We have applied forces to each element. So I think this is a good roundup for understanding some of the basics of SceneKit, and I hope you had fun. And let me know if you would like to see more of those tutorials about games using SceneKit. Check out the new Numa Community. Thank you so much for watching, and I'll see you next week.